Hi, 8th grade. So now I am filming module 12.5. We're going to talk about distributions of data. And in this, let's look at our learning target. I can interpret differences in the shapes of distributions, account for the possible effects of extreme data points. So, in this, we are basically going to be talking about is the data going to give me a symmetric graph? Is it going to give me a graph where the mean is skewed right? Is it skewed left? What should we use when there's an outlier? So all these kind of things we have been doing since 6th grade. So this is going to be a pure repetition of all that material taught since a younger grade to you all. Now, I know that when I am looking at my the shape of a distribution and I'm analyzing the shape of a distribution, this can help me. So look, I'm just going to show you over here. So there we go. So when I'm analyzing the shape of a distribution, this can help me learn a lot about the data that it represents. Okay, and when data are graphed, the shape of the distribution can be seen. So I have given you a histogram, a box plot, and a dot plot. 3 of them over here. So as you can see, in a symmetric distribution, the mean and median are approximately equal. Okay, so as you can see, the data are evenly distributed over here. Okay, and we always look at the tallest bar, and I've taught you that in 6th grade and of course in 7th grade. And we always go here, and then we look at this and this measure. We look at the tail lengths. And if the tail lengths are the same, we know that this is a symmetric distribution. Data are evenly distributed. And then same thing with the box plot. We go to the median and we know here's the median. And then we look at this portion and this portion. So look at the tail lengths. They are the same. And then we look at the dot plot. We go to the highest. And then we look at this distance and this distance. So as you can see, in all of them, the data are evenly distributed. And in this one, the whiskers are the same length. The median is in the center of the data. So as you can see, this is telling me that this is a symmetric distribution. And so the mean and median are approximately the same. The mean and median are approximately the same. Okay, in this case, when it is symmetric. Now, let's look at when the graphs are skewed in either direction. All right, so here are 3. Again, I'm giving you an example of each. And all of these, I can see that the data, the mean is going to be less than the median. Because look, if I look at the tallest spot and I look at this and then I look at this. And same thing here, I go to the median, I look at this and then I look at this much. And then I go to either of these, I can go here and I look at this and I look at this spot. So you can see the tail end on the left. Okay, I can also do this. I can do this. All right, same thing for this one. Look, here. So just looking at this, I know that my graph, looking at the long tail end, it is going to be skewed left. And so basically, I know that there is either an outlier or something, and this is pulling my mean down. So in situations like this, my mean is less than the median. Mean is less than the median because all these values on the left are going to pull the mean down. Okay, so this is also called a negatively skewed distribution and typically has a median which is greater than the mean, and that's what I just said. So just go ahead and look at this once again. And in that one, fewer data on the left whisker is longer than the right. So see, and the median is closer to the shorter whisker here. Okay, so therefore this is skewed left. And in this one, fewer data on the left. So let's look at one which is now positively skewed. So here's one which is positively skewed, or we can say it's skewed right. So if you look over here, again, I'm going to do this and look at the tail end. Okay, it has a much longer tail end to the right. Let's look at this one. Here's my median, and look at this compared to this. This is longer. Then let's look at this one again. If I take this and I go this way and this way. So look, I can also do this here, or I can do this. So this is telling me that this is skewed right, or positively skewed. So that means my numbers to the right are going to pull my mean up. So in this case, my mean is greater than my median. When it's skewed right, the mean is greater than the median. Okay, so these are just some examples that I wanted you to see, and these are all the shapes of the distributions. So when we are analyzing distribution, the most important thing to remember is when it is symmetric, then we are going to use mean, and we are going to use mean absolute deviation or standard deviation to see the variation in the data. Okay, so we can use mean and again mean and standard deviation. All right, now when it's negatively skewed or it's positively skewed, you know that the mean is greatly affected by the outlier. So in that case, I'm going to use the median, and I'm going to use the 5-number system, the interquartile range. Okay, so let's look again over here. A symmetric. So look, I use mean. There's no outlier, there's nothing pulling the data way down or on the other extreme way up. So in this case, we use mean and standard deviation. However, when it is negatively skewed, we can see that my mean is going to be less than my median. So in this case, we are going to use the 5-number summary. So we are going to use the median. And definitely I am going to use IQR to see the variability in the data, in the quartile range. On the other hand, what is the mean? The mean is going to be greater than the median because it is skewed right. See here, in this case it was this way. So because of these numbers affecting the mean, we are again going to use my IQR, which is my interquartile range, to check for variability, which is the 5-number summary. And we're also going to use median because median is not affected by an outlier. Okay, so whenever analyzing the distributions, please remember this. When it's symmetric, use mean. When it's not symmetric, meaning it's skewed left, skewed right, etc., use median. All right, the rest of this lesson is all about using technology, using a graphing calculator to construct a histogram or a box plot for the data, and then to describe the shape of the distribution. Okay, now I know that in middle school you don't normally have a graphing calculator. I would suggest Desmos. Okay, that can also be used for a whole lot of your quadratic function graphing, all function graphing. Desmos would be a great one to use. I have also used some other online versions of graphing histograms. So let me show you, as well as box plots. And we're just going to take this data and we are going to enter it into one of the platforms that I am using. So I used this website to just, input my values, and it created a histogram for me. So this is one of those. You can use Desmos also. That will also do it for you. And what I did was I entered the values, and you basically have a column. So in the column, I went ahead and input all the values that were just provided to me in the earlier slide, and then it does the rest. It's given the frequency, and it went ahead, and I also selected that I want the intervals in tens, and so this is what it gave me. All right, so once I have this, I can see the frequency for each. I know that this graph, this is my high end. So my left tail end is much longer than my right tail end, right? So this graph is skewed left. And because my graph is skewed left, I know that these lower values are pulling my mean down. So in this case, because it's skewed left, I am going to use median, and I am going to use my interquartile range for the variability of the data. Okay, and so again, the histogram is higher on the right and has a tail on the left, therefore it is negatively skewed. Desmos. And this, y'all, you can do all kinds of cool calculator stuff on this, and you don't even need a scientific calculator because it's got everything. You can enter functions and it will graph for you everything. Okay, so yeah, this is a cool one to have and keep. All right, so if I click on this, for example, see, and I just have to put in, this is the histogram creator, and you just put in your values, etc., and it will just plot it out. Okay, so this is what I wanted to show you also. Okay, and it has all these other calculators also, the Desmos does, as you can see all the stuff. The point slope form, it's got the slope intercept form, the parabolas, vertex form, etc., etc. So you just have to write out the function and it will plot it for you. Okay, so these are so many different things that you can do with these over here. So look, so this is a good one to use. And see, if you had done it on a scientific calculator, you would have ended up with exactly the same histogram that I just showed you that I had done on that website that I had pulled up. Okay, nowadays you can basically search anything, create a box and whisker plot, create a histogram, etc., etc., and you will find it. So you can find something that it'll create it for you when you input the values. So this is the website that I found for a box plot maker. And when I click on this, all I have to do is enter the values over here, and I'm going to show you in a minute, and literally it creates it for me. Okay, so let's go on and look at a box and whisker plot that I created using those values. So as you can see, all those values that I just showed you, I put this, you've got to just keep hitting enter, 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 and you put it in a column. Enter the data from Excel also, but I chose to do it like this, and then let me show you what I got. So this is what it created for me. And as you can see, this box plot, it is skewed left. So because it's skewed left, I would use my IQR for variability, and I would use a median to analyze the data. Okay, but this is what was created by that website that I just showed you. Okay, again, box plot, it can be done on Desmos also. Okay. And the website that I just gave you, it does this calculation also with the box plot. It's telling you what your first quartile is, what your median is, what your third quartile is, what is your upper boundary, what is your lower boundary. Everything is provided. So it's doing all that calculation for me. And then if you had used a scientific calculator, you can see you've got the same box plot drawn out. And so you're entering the data and graphing the box plot. As you can see, the left whisker is longer than the right, and the median is closer to the shorter whisker. Therefore, the distribution is negatively skewed. So everything that I just showed you on that website, it can be done on the graphing calculator also. Okay? So here's another question. Use a histogram or box plot to determine the shape of the data. So I chose to make a histogram with that website that I had just shown you, where I can create a histogram. So look at all the values over here, and then I'm going to show you the shape of the distribution based on the values that I input. And here it is. So once again, this is the website that I used. And it just, I input the values, it did all the frequency count and all that stuff, and it created this for me. And looking at this, I can see that what is going on, that it is a symmetric distribution. Both sides look exactly the same. So therefore, this is going to be a symmetric distribution. Okay, so because it's symmetric, what's the best measure to analyze the data? It's going to be mean. All right. So here's another one. Once again, as I told you, this whole thing is very technology based, and we're describing the center and spread of the data using either the mean and standard deviation or the 5-number summary. And we're going to justify our choice by constructing a histogram for the data. So once again, I'm going to show you with the scientific calculator, but I'm also going to show you what I created with the box plot maker. With the scientific calculator, I'm going to show you a histogram. So with that data that I just showed you, this is what happens when you put it into a scientific calculator, a graphing calculator, sorry. And then look at this. If I do this, if I look at both the ends, the tail ends are pretty even. All right, so using a graphing calculator, we are creating a histogram, and then the graph shows that the frequency of the data in the middle is high, and then the frequency of data to the left and the right are low. Therefore, the distribution is symmetric. So if it's symmetric, it is always good to use mean. And then these are the other things that the calculator does show up. It gives us all of these values here. So I can look that the mean is about 16.4 if I round it. And then I can see that my standard deviation, the sigma sign over here, is telling me the 6.95, etc. This is about 7. Okay, so the distribution is symmetric. Mean and standard deviation are good statistics to represent the data. And so this is all in the calculator. And this should show up in the website also, the link that I had provided you. Okay, so then here's the box plot that I created with that same data value where the histogram was created, but I took those numbers. This time I just put them in the correct order. You don't have to. If you can just stick it there and it will do all the calculations for you, but I chose to put it in the correct order. And then I entered it in here like this. And then let's look at our box plot. And here, there you go, statskingdom.com, and then of course /advanced-boxplot-maker.html. That's where I created this. And there's the distribution. Once again, whether it was the histogram or whether it's the box plot, it is showing me that this is pretty symmetric. Okay? And so when we have symmetric, we use the mean to analyze the data. Okay, and then standard deviation for any variation in that data. And of course, along with that, it also gives me, with the box plot, it's giving me what the first quartile, third quartile, median, upper boundary, maximum, minimum, etc. Everything is provided. The mean, as we had said earlier, that the mean was about 16.4. So look, same thing here. This has already calculated for me also. Whether I do it on the graphing calculator or I do it here, I'm still getting the same results. So last thing, let's quickly talk about our extreme data points. And of course, we have extreme values. And extreme values are the least and greatest value of the data set. And these are, of course, the smallest or the largest in that data set, and that is what extreme values are. And then we have outliers. An outlier is a number which is way higher or way lower than the rest of the data set. And in order to calculate an outlier, we definitely have a rule, okay? So an outlier is always calculated. First, you have to find out the interquartile range. And then you have to do 1.5 times the IQR. Okay, so you have to do 1.5 times the IQR to find out if the outlier, if a number is much bigger than the rest of the data set. I have to do my third quartile plus the 1.5 times IQR. And to find at the lower end, I have to do my first quartile minus 1.5 times the IQR. So I have to calculate the interquartile range. Then I will go to my, of course, I will go to my third quartile. I have to have my 5 points that are required for plotting a box and whisker plot. My smallest number, largest number, median, first quartile, third quartile. But in this case, I have to find the outlier, whether we have an outlier. I'm going to take my third quartile that I've calculated, and I'm going to add 1.5 times the IQR. If a number is, after the calculation, if you see a number in the data set that falls in this category, that would be an IQR, or that would be an outlier. And at the lower end, what I would have to, because it's going to be a number which is way smaller, so I'm going to take the first quartile and I'm going to subtract that 1.5 times IQR. And then if I have a number that falls in that category, that is going to be my outlier. So yes, I can have an outlier at both ends, or I may not have an outlier, okay? And I might have an outlier just at one end of the data set. But this is the outlier rule that we all need to know in order to calculate our outliers, okay? And of course, extreme values are the least and greatest value of the data set. So here's the last question. Once again, everything is calculator based in this module. And then we can see that, let's see what it's saying. Choose appropriate statistics with extreme data points. So sharks. The lengths and feet of adult sharks of various species are shown. Describe the center and spread of the data using appropriate statistics and identify the effect of extreme data points. Okay, so here's the first thing, and then I'm going to put it into one of the, either the website that I gave you or into my scientific calculator, and let me show you what I'm going to end up with. With the values provided, this is what the calculator is doing. Okay, we made a box plot, and we can see when analyzing the data, we can notice that the right whisker is longer than the left whisker. So we know that this distribution is skewed right, or it is positively skewed. And so the plot also shows that there is an outlier, and the outlier is always marked with a little asterisk. Okay, so it's telling me that there is an outlier over here. Okay, I don't know if you can see that really clearly, but whenever we are showing an outlier, we have a little asterisk that is showing up like this. And that is telling me that an outlier is over there. Okay, and so when I do the calculation, everything else, it is also going to do it for me. It will show me my mean with the 5-number summary to see the effect of the outlier, and it gives me my mean as 13.82 is giving me my median. Okay, it's giving me my median as 12. It's giving me my maximum, which is 46. Maximum is 46. Minimum over here I am getting as 6/10. And then I have my lower quartile, so that means my first, I'm just going to write Q1, lower quartile, it's giving me as 5.85, and my upper quartile, which is Q3, is being given to me as 19. My IQR is going to be my third quartile minus my first quartile, and is going to give me 13.15. 13.15. And since 46, that's the maximum number, is more than what is my Q3? So my third quartile plus 1.5 times my IQR, okay, which is this, because we are trying to see, do I have an outlier? So this is my Q3 plus 1.5 times IQR. That's what I've done, which is my outlier rule. Because with this calculation, I get approximately 38.7. Okay? So about this, because I rounded it, that's why I said this value. So when I'm looking at this maximum value, which is 46, is that greater than this? Yes. So that is why that is my outlier. So I can see all that just by looking at all the data that is provided to me. And describing the effect of the outlier, I can see that since 46 is an outlier, it has affected the mean. And to see how much, we are going to remove 46 from the set of data and display the statistics again. And then if I remove the 46, if I remove the outlier, I'm going to end up with the mean without the outlier as 12.12. So look, that becomes much closer. The median did not change, but of course the mean is going to be affected. So once again, median is not affected by an outlier, but the mean is. So it came down from 13.82 to 12.12. Without the outlier, the mean and median are closer to the same value, as you can see. Okay? And that's basically what this entire lesson is about, guys. Pretty clear cut and super simple, especially with technology that you can use in this. It makes graphing super simple. You can either make a histogram or make a box plot. And in the classroom, I will place those links into your folders, so you'll be able to just open that. Once again, Desmos is also a great one, but I will make it available in the classroom in your folder, so you can just click on it and you can create the histograms and the box plots, okay? But once again, this is all about distributions of data, and we know that if it's symmetric, please use mean, and you can use standard deviation for variation, how far something is from the mean, how much is varying from the mean. And in the last module, I taught you how to calculate standard deviation. If you remember, you subtract the value from the mean, you square it, and then you add up all those squared values, divide by how many numbers they are, and then the square root of the entire thing. That tells you the deviation, okay? And then, of course, if it's skewed right or skewed left, that means there might be an outlier which is affecting the mean. It's either pulling it up if it's at the upper end, or it's pulling it down if it's at the lower end. So the outlier does affect the mean. So you want to make sure when you have an outlier, you want to use the median to analyze the data. And of course, my interquartile range is a good one to see the variability in the data, which is skewed, right or left, okay? And also, of course, please remember the outlier rule. And the outlier rule is you are taking the interquartile range and you are multiplying it with 1 and 5/10, so 1.5 times IQR. And for the upper end, you've got to add it to the third quartile, and for the lower end, you've got to subtract it from the first quartile to know if you have an outlier or not. And that's about what module 12.5 is about, distributions of data. Have a great day, everyone.